Factoring quadratic expressions. There are too many expressions that can be factored, but now we are only factoring expressions that can be quadratic equations or quadratic functions. So we're going to talk about 4 ways to factoring. The first will be difference of squares. The second will be x squared plus bx plus c, trinomial. The third will be ax plus bx plus c, trinomial. Notice that there's a difference between the second and the third because a is a different number in the third form. And the fourth way that we are going to factor is perfect square, trinomial. Difference of squares. And a difference of squares is always a binomial where the two terms have different signs. For example, x squared plus 9, they are two terms and they have different signs. For x squared minus 100, two terms with different signs. 1/16 x squared minus 36, two terms with different signs. Negative 25x squared plus 4 and 72x squared minus 98. So we can factor these expressions by using the simple formula for the difference of squares. You only have to take the square root of both terms. The square root of x squared is x, and the square root of 9 is 3, and put them in parentheses, separate by a positive sign, and then separate by a negative sign. So remember, the square root of x squared is x, and the square root of 9 is 3. Then you put those roots in parentheses, separate by a positive sign and by a negative sign. Then here the square roots are 2x and 10. So 2x plus 10 and 2x minus 10. 2x plus 10 and 2x minus 10. Here 1/4 of x and 6. So 1/4 of x plus 6 and 1/4 of x minus 6. And here notice that the negative is in the first term, so the different signs will be with the first term. So you will have 5x plus 2 and negative 5x plus 2. And the last expression should be factored with a common factor on first. If we divide all the expressions by 2, we will have 35x squared minus 49. And now the difference of squares is inside the parentheses. So you copy the 2 and factor this expression. 6x plus 7 and 6x minus 7. So this 2 is part of the answer. Now we will see the x squared plus bx plus c trinomial. In its name you can see that they will be 3 terms. So the first will be x squared plus 2x minus 15. The second will be x squared plus 2x minus 24. The third will be x squared minus 5x minus 14, and the fourth will be x squared plus 17x plus 72. And now the way that we are going to solve is as simpler as simple as follows. The first thing, we identified that these terms are in order because we have first a squared, then an x with an exponent equals 1, and then we don't have an x. And all the examples are ordered in this case. Not always will be ordered. So the way we are going to solve is you write parentheses, which means that they will be two factors, and then copy x in both parentheses. And then this sign must be copied. So plus, and for this sign of here, you must multiply. Plus times negative times minus is minus. So since they are different signs, you will look for two numbers that multiply are equal 15 and subtract are equals 2. So 5 times 3 is 15 and subtract are 2. You write on first the biggest, the greatest, and then the smallest. It's a 3, sorry. Here, x and x, the first sign must be copied and the second sign must be multiplied. Plus times minus is minus. Two numbers multiplied are 24 and subtracted are 2. So they are 6 and 4. And this is the answer. Here, for example, you will have x and x. Copy the first sign, which is negative, and then the second must be multiplied. Minus times minus is positive. Because they are different signs, you must say two numbers multiplied are 14 and subtracted are 5. So they are 7 and 2. And in the last one, x and x, the first sign is plus, the second sign is plus times plus is plus. And then two numbers that multiply are 7 and 2. And added, because they are the same sign, are 17. They are 9 and 8. And those are the answers of these 4 examples. The third way that we are going to factor is ax squared plus bx plus c. But notice that the difference between the last one and this one is the a, because a will be a number different than 1. So the examples will be 3x squared minus 2x minus 8, 15x squared minus 10x minus 5, and 4x squared minus 19x plus 12. So the principle is the same that the previous way to factor, but here we must add some steps. The first step that we will add is to multiply a times c, which is 24. So instead of thinking on an 8, we will think of a 24. So we will use the same principle, which is 2 parentheses and then 3x because of these 3, and the x will be without the square. 3x and 3x. So the first sign must be copied and the second sign must be multiplied. Minus times minus is plus. So you will find, or you will look for two numbers which multiplied are 24 and subtract are 2. They are 6 and 4. Do you remember? The first one must be the greatest and the second one must be the smallest. Then you must find a common factor. Here, this is the common factor is 3. So this parenthesis will be x minus 2. And here, there is not a common factor. So you copy this parenthesis. Then you divide over a because you multiplied in the beginning times a. So a is 3. You always will notice that you must cancel this number with this number, and the answer is x minus 2 through x plus 4. And that's it. So here we will repeat steps. 15 times 5 is 75. Right. Now, parentheses, 15x, first sign must be copied, negative, and minus times minus is plus. So you will find two numbers which multiplied are 75 and subtracted, because they are different signs, are 10. They will be 15 and 5. 15 on first and 5 on second. Then you will find a common factor. Here the common factor is 15, so you will have x minus 1, and here the common factor is 5, so you will have x plus 1. Then you divide over 15 because you multiplied in the beginning times 15. So eliminate these two numbers and the answer will be 5 times x minus 1 times x plus 1. And that's it. The third example will be 4 times 12 is 48. So you will have 4x minus, and 4x minus times plus is minus. You will look for two numbers such multiplied are 48 and added, because they are the same sign, are 19. So the numbers can be added 19, 16 times 3. So 16 times 3 are multiplied 48 and added 19. So you look for the common factor. Only in the first parenthesis is a common factor, which is x minus 4 times 4. And the second parenthesis doesn't have a common factor. You divide over 4 because you multiplied by 4 in the first step. And then you have the answer, x minus 4 and 4x minus 3. And this is the answer of every example. The perfect square trinomial can be solved in the same way we solved the two previous forms of factoring, but there is a special way to solve a perfect square and a special way to identify if we have a perfect square. So we will have the following examples: x squared minus 4x plus 4, 25x squared plus 10x plus 1, 16x squared minus 24x plus 9, and the last one, will be 25x squared plus 70x plus 49. So the most important thing is to prove that they are perfect squares. How to prove that? You must take the square root of the first, then the square root of the last, then multiply all of them uh, times 2, and you will have 4x in this case, and this is the same term that we have here. Okay, so this is a perfect square. This is not the answer, only the proof, but we are going to try with this one. Square root is 5, square root is 1, times 2 equals 5x times 2 is 10x times 1 is 10x, which are the same numbers. This is a perfect square. Here we have 4x times 2 times the square root of 9 is 3. 4x times 2 is 8x times 3 is 24x. And this one, 5x times 2 times 7. 5x times 2 is 10x. 10x times 7 is 70x. So all of them are perfect squares because the proof, this is the proof, because they are the same numbers that we have in the middle. Okay, so now we are going to solve how to solve these expressions. We must take into account only the square root of each term, the first and the third, only the square roots, and the sign of the second term. So you will say x minus 2 squared, 5x plus 1 squared, 4x minus 3 squared, 5x plus 7 squared. And those are the answers. The squares by a binomial squared is the answer of a perfect square trinomial.